the standard normal distribution. Standardizing a normal distribution. Okay, we start off with any normal distribution. So let's say we've got a normal distribution for heights of students. It's like this, 160 and a variance of 25. The mean 160, variance 25. And if we randomly select a student from this population, we're trying to work out the probability that the height of the student is less than 162.1 centimeters. Okay, now the first step is to standardize using this formula. So we take this value here, and this is represented by x in this formula. So we do z is equal to x, which is 162.1, minus the mean. The mean is 160. Okay, there's the mean there. That's the variance. Divided by the standard deviation. The variance is 25, so the standard deviation is the square root of 25, which gives us this. So now using our calculator, 162.1 minus 160 divided by the standard deviation, and that gives this value, 0.42. And z should be rounded to three significant, well, not three significant figures, but three decimal places. So z is equal to 0.420. And then we go on to our next step, which is to do a sketch of the normal distribution, but the standard normal distribution representing z. Okay, so here's my standard normal distribution. The mean is 0. Z values along here. 0.42 is about there somewhere, 0.42. So we're looking at less than, so we're shading to the left. Okay, so I'm trying to work out this at the moment, the probability that z is less than 0.420. So shading to the left, like this. And then we go to the tables to look up 0.42. There's 0.4. There's the 2. The third decimal place was 0, so there's nothing to do here. There's no 0 there. We're not doing anything here. 0.42, so that gives us 0.6628. So that probability there, 0.6628. So that's the answer. So the probability is 0.6628. That's what we're looking for. Okay, so the probability that we select a student randomly from this population and that the height of the student is less than 162.1 centimeters is 0.6628. So these are the basic steps. You start off with some normal distribution, you standardize by using this formula, and then you sketch the standard normal distribution. You go to the probability tables and you look up your probability. And this works in both directions. In some questions they give you the probability, so you mark the probability on the sketch, you work out z, and then you rearrange the formula here because you know z, you've just worked it out, you know sigma, you know the mean, you rearrange this to work out what x is equal to. Okay, so if we rearrange this formula, if we make x the subject, we have x is equal to population mean plus z times sigma, and the mean is equal to x minus z times sigma. And the standard deviation, it's like if you swap the z and the sigma around, you get x minus the mean over z. Okay, let's have a look at an example on standardizing to calculate probabilities. We have a mean of 48 in this normal distribution and a variance of 17. Okay, so the mean is 48, the variance is 17, and the standard deviation is the square root of the variance. Okay, so the first step is applying the formula and standardizing. So we're going to work out the probability that z, okay, so that t becomes z, the standard normal variable. That says less than, so you just copy that, less than. So we're standardizing 43 minus the mean, so minus 48, divided by the standard deviation, square root of 17. And we need to round this to 3 decimal places, so minus 1.213. So now we have a sketch of our standard normal distribution. Minus 1.213 is about here. It says less than in the question. So we've got this. The z value here is negative, but ignore the sign. Go to the tables and look up 1.213. Okay, ignore that minus. Just look up 1.213 from the probability table. Okay, so 1.2, ignoring the minus, 1.2 is here. So we're in this row. So that's the first decimal point. The second decimal point is 1, which is here. So that takes us to this value here, 0.8869. And then the third decimal point is 3. The third decimal point is 3. And that's this value that we have to add on. Okay, so we have to add on 6, like this. You can put the zeros in, just add that together. Okay, so 8869 plus 6, and that gives 0.8875. And we're almost there. So 0.8875. And if you think this side, the shaded side, represents that probability, you would be wrong, because clearly we've shaded in less than half of this sketch, so the probability here should be below 0.5. That value there belongs to the other side, so that goes here. So the value here will be 1 minus what we've looked up. Okay, so 1 minus 0.8875. So 0.1125. That's the answer. There. Okay, so if you have negative z values, ignore the sign and just look up the positive value, 1.213. You go to the tables, you look up your probability from here, you come back to your sketch, and if you have shaded less than a half of the sketch, you always do 1 minus. If you've shaded more than a half, the value you've looked up from the tables is the final answer. If you get a question like this, where you're looking for the probability that something is between two values, then you do two separate calculations, so work out the probability of less than the first value. Okay, that's always less than for a question like this. And separately work out the probability that you have less than the second value. And again, this will always be less than if your question is like this to begin with, between two values. And standardize both of these, do the sketch, work out the probabilities, and so you've done some working out here, and you've got a couple of probabilities now. And then your final step is to subtract. Okay, so you've done two separate calculations, you subtract these two probabilities, the largest one minus the smallest one, to get your final answer, which is the answer to this. Okay, so just to go over this once more, if you have a question where you're trying to work out the probability that you have something between two values, you always work out less than for both values. So then you have two separate probabilities that you've calculated, and then you subtract these two to get your final answer. In this problem, we're already given the probability, which is 0.82 or 82%, and we're trying to work out this unknown value of x. So the first step, we just summarize the mean, variance, and standard deviation. So we're starting here with the probability, working backwards, so working from the right towards the left, do the sketch and work out any missing z values. And we can see from here we're going to shade to the right because it says x is more than, so we shade this probability to the right, so 82% to the right, so we can draw a line here somewhere and shade this region in. So that probability there is 0.82, which means this side would be 0.18, and you should mark in the probabilities for all the regions on your sketch, whether you've shaded the region or not. And then starting with the probability out of these two, the one that's more than 50% or more than 0.5, we go to the tables. And from here, it's going to be the 0.82 that we're going to look up from the tables. Okay, so we have our normal distribution tables here. And I say tables because they are two. You've got the main table here and there's another one underneath. And we're starting off with a probability and we're trying to work out z. In this table here, you have a few select probabilities which are commonly used in statistics and their corresponding z values. And the first thing we notice, 0.82 is not in here, so we can't use this table here. We have to use the main one. Now look at the probabilities and go through them until you get close to 0.82 without going over. So that's there. Yeah, that's gone over 0.82. So we start with this one. And that gives us a z value of 0.91. Okay, so write down the first few numbers there, 0.91. So we've got the first and second decimal point. We now need to work out the third decimal point. And to work out the third decimal point, we can see from that 86, if we add 14, that becomes 0.82. So we want to add 14 to this. So go to the right hand side here. So that's adding 3, 5, that's adding 8, that's adding 13, that's adding 15. 14 is not in there. So you can go with either one of these two. And I'm going to go with the 13 there. And that's telling me that the third decimal point for z will be 5. Okay, so that's 5. So 0.915. So if I write my z value here, 0.915, on this number line, 0 is in the center here. So this value here is actually negative. You've got negative values on this side and positive values on this side, so it's minus 0.915. Okay, that's my z value minus 0.915. And then you go to your standardizing formula, and because we're trying to work out what x is equal to, I need to rearrange this. So x is equal to the mean plus z sigma, and then just substitute the values that we have into this. So x is equal to the mean, which was 6, plus z times sigma, and z is minus 0.915 times sigma, which is 2. So we have 6 plus minus 0.915 times 2, and that gives 4.17. So x is equal to 4.17. So what we've worked out is that the probability that x takes a value that's more than 4.17 is equal to 0.82. That's the value of x that we were calling t in this question. So, things to look out for when probability is given. So you're starting with the probability, and you're going to do a sketch first, and you're going to mark that probability on there. Okay, so we've marked the line there, and this arrow is pointing to the right, so you know you're going to shade that probability to the right of this line. Once you've done that, the cumulative probability to the left of this line is 0.18, to the right is 0.82. Look up the one that's more than 0.5, which in this case is 0.82. So then you go to the tables, it's over here, and these are the probabilities in the center with z values on the outside. The probability we have is 0.82, and that's the value that's the closest without going over. You must not go over the value you're looking for. And 0.91 will give you the first and second decimal point. So to make this up to 0.82, we need to add 14 to this. So just follow that row to the end, and adding 14 means we can use either of these two. If I stick with the 13 there, it means 5 is my third decimal point. Okay, so 0.91 and then 5 from the other side. And then you need to check the sign of z. If you've drawn your line on the left-hand side, it's going to be negative, and if that line was on the right-hand side, it would be positive. And then you go to your standardizing formula, rearrange that to make x the subject, substitute the values in, make sure you check the sign of z, that it's accurate, and you've got the value that you're looking for.